another video. It's been a while since I made a video, been kind of busy with life and the bullshit that comes with it. But in any case, I'm back and I have this circuit here that I'm going to show you. It's a sort of game with a lamp, and it's all interactive. But I'm going to show you first a video just to give you an idea of what I'm going to explain in this video, and then we're going to have a look exactly how I've built this circuit and what to do if you want to build it yourself. So first of all, I'm going to start by saying that this is a sort of game. It's a very basic and simple game, and you can see it's made out of a panel and a lamp, and the way it works is basically it resembles a sort of sci-fi nuclear reactor that you need to shut off, and the game gives you instructions and you need to follow them by providing the correct inputs, and you get feedback from this lamp that you see. You can see the panel, it's very basic. It has an LCD screen and just switches that indicate what each of the switches does. Here you can see the lamp. It has some nice effects that I've put in it, and it's controlled by a microcontroller. We're going to have a look at it in a moment. It has effects that are meant to make it look like some sort of a reactor, a sci-fi reactor. And you can see here how the game itself is played, where basically you get instructions on the screen and you need to just load the correct inputs and follow the instructions. Eventually, once you follow all the instructions that are set in the code, they are random ones, but once you follow all of them, then something happens. I didn't finish it completely, but as you can see, you just get these instructions and you need to load the correct sequence and just follow it until the reactor is stabilized, quotes. In the meantime, it also gives you sort of feedback, what happens, meltdown, and all sorts of things. But it's really nice, and you can see here that we reached the end of the game, and that's it. It will restart. So I'm gonna just cover some things here. Sorry for that. As you can see, just like you saw in the previous video, here we have the lamp, and here we have the panel, and the panel, as you can see again, it switches. It's asking to follow instructions. Right now it's resetting. It has reached the end of the cycle, but this is kind of messy. I don't have a large enough shot to give you a clear overview. So I'm gonna take apart the lamp and the logic bit, and we're gonna cover each part separately. Perhaps this video is gonna be 2 parts, I don't know yet, depends how long it's gonna be, but I'll be right back, and we'll focus first on the logic, and then we're gonna see how I've made the lamp itself. So just a moment and I'll be right back. Okay, so we're back, and we have here only the logic bit. I've removed the lamp. The lamp also has a microcontroller, but this is the part that actually controls all the rules and everything that needs to make this thing work. Let's just have a look. So you can see the panel here. The game is currently on, and I don't know if you can see it clearly on the camera on the video, but we have some LEDs here. They indicate which switches we need to load here at the bottom. Here is the LCD. It gives us the instructions. So for example, load the reaction frequency, And these are just sci-fi terms that I've given it to give it a little bit of theme. The basic goal is to just set the switches accordingly, and you can see that once I've done that, then we have the load light that comes on, and once I load it, then it should load, but it probably shorted out here because I've put everything together. But in any case, that's the way it works. Let's have a look at the circuit. So this is, you can see here, I'm going to try to do this carefully, but here you can see the panel that I've created. It's a piece of plexiglass, and I hope that you can see it clearly on the camera. It has these switches. The idea was to make a sort of panel that looks like a 60s, 70s military panel with all sorts of names to give it a theme, sci-fi names. We have the neutron flux generator and a fusion drive and a core sequence, and it's just to give it a little bit of character. We can see here a little print board which has resistors to operate the LEDs, and at the back you can see just all the connections, all the buttons, all the switches, sorry, they receive high. You can see here all the voltage just crossing from switch to switch, and the rest is, you can see here all these strings, all these wires. It looks a bit messy, but there's not a lot to this circuit. It's just a bunch of wires that you can see. And if I put this on the side for a moment and turn it off, then if I remove all of these, then you see here that this is the part that actually communicates with the panel. And here we have another string that comes to the LCD. Basically, most of the wires that you see here, they're just jumpers. So here we have the string that comes from the LCD, and it will go here and it will jump to this place, but I didn't have enough room here, so I jumped to another board which has the 80 mega, and this is an 80 mega 32. I used the 32 instead of an 8 because the code was too big and it didn't fit. Here we have a voltage regulator, so it's going to drop from 12 to 5, and the LED lamp receives 12 volts, and the rest of the logic and also the microcontroller on the LED lamp also receives 5 volts. I'm going to talk a little bit about the way that the game works. Now before that, if you want to build it, I'm going to mention all the parts here, and you only need to go and watch videos, previous videos that I made on each one of these components, and you simply build it exactly like it's in the video, and then you just connect them together in the only logical way possible. And that's exactly how I did this, and the way that this works. So the way this game works, again, we have here a microcontroller, an 80 mega 32. It basically has all the rules and it controls everything. And here we have 6 chips. The 2 in the middle, they are 2 shift registers, and on the side of each shift register there are 2 quad 2-bit comparators, which together they make 8 bits, and these comparators are what interfaces with the panel. So we have here buttons, 16 switches, sorry. And these lower 8s, they interface with these 2 comparators, and these ones, they interface with these 2 comparators. And the whole idea is that the 80 mega generates 2 bytes. It pushes them through the shift registers. The shift registers, they are connected serially, so that means that the bytes, they go into the first shift register and moves on to the second one, and then it loads the parallel output to the quad comparators, and we need to match whatever value comes out. So the idea is that these switches here that we are setting on and off, we are basically matching the value of the 2 bytes that came here. The 80 mega here will control which part of the panel is operated. So it's either the lower section or the top section or both, but I didn't implement it in the code. It's worth mentioning that right now the circuit is entirely it's complete. So that means that if there's any changes that I want to make to the rules or the way that everything works, I only need to do that by changing the code inside the microcontroller. Nothing needs to be changed in the circuit itself. Pretty simple. All the resistors here that you see that go into the quad comparators, 220 ohms. The rest of the resistors that you see that go into the shift registers, and the pull downs and the pull ups that go into the microcontroller, they're just 1K resistors. And that's pretty much it. It's very simple, very easy to make. Again, watch previous videos that I made. I'm not gonna make schematics for this because again, you just need to follow the videos just like I did and just build it. That's it. That's the logic part of it. I'm gonna set it aside, and we're gonna see how I made the lamp, and I'll be back in a moment. And we're back, and you can see here we have the lamp. It's on right now, but it doesn't do anything because it needs the other microcontroller to give it command so that it will switch between the different effects. Right now it's just on. It's not even the effect of the let's say the reactor. But let me just turn the light on, and we're gonna see what the circuit here under looks like, and the way that the lamp is built. So just gonna turn it off. Here we have the circuit. This is the same voltage regulator that was used for the two circuits together. Again, it receives 12 volts. The 12 volts is needed to operate the LED strips. There are LED strips inside here. We're going to see them shortly. And 5 volts operates this 80 mega 8 this time, because it didn't need that much code, so I could just use that one. And here we have two tip 121, which just NPN transistors. They control the green and red LEDs. There are 3 LED strips in the lamp, and these 2 resistors control all 3. One only for the green, one only for the red. Next to them we have 3 3904s. They control, each one controls just a single LED strip and just the blue color. So they give the effect of the blue sparks, and the 2 big ones here, they control the red and the green. The lamp itself, you can, I just put a piece of paper to diffuse it, because otherwise you won't be seeing that good on camera. But let me just take this off. I'm going to take apart this circuit anyway. I've just built it for this video, just to share it with you, and for those who like to do their own little projects. But this is the lamp. Turning it on. Disconnected something. Oh, here we go. So you can see that right now the effect is starting, and that's the way the lamp works. It has these 3 pieces of plexiglass inside, and I can just take them out. like this. And here you can see the piece of plexiglass. That's what actually gives the light. And here at the back there is an LED strip, an RGB, 12 volts, and that is what gives the effect of the light. So yeah, that pretty much was it. Very easy to follow. I hope that I covered everything. I've been sort of not in the right place in general, and I probably forgot to mention something. So if you have any questions, then just feel free to leave them in the comments. If you want the source codes for these for the two microcontrollers, then just send me an email and I will send it to you. And if you want a list of parts, then I can also send it to you. That's it. Yeah, I've covered everything about this little game. When you're looking at it, just to sum it up, you need to think a little bit out of the box. So you just saw a panel and this LED, but again, the circuit itself can be just put on every other theme that you might think of. This lamp can be removed and it can be replaced with another mechanism to give a sort of output or feedback to the user using it. The panel can be replaced, the switches can be replaced, but the circuit itself and the code, they just remain the same, and just the theme around it changes, and that's how you create variations of these little games. That's it. I hope you like it. Again, if you have any questions, feel free to leave a comment. If you haven't subscribed yet to my channel, then please do, because it always encourages me to make more of these projects, just to share it with you. I am making everything on breadboard because I believe that when you look at it on a breadboard, it's easier to see how it was made and how it's done, instead of, for example, showing you a print plate like this one, which is a proto board, and this is the exact same circuit that you saw previously, and here we have the 280 megas. It's not done yet, but it would be far easier to just show you this breadboard. Hope you liked it, and I'll see you next time. Thank you for watching.